All right, welcome to lesson number 2 on inverses and contrapositives of conditional statements. So just as a quick review, if we go down here to the bottom, remember we've looked at a conditional statement which has the form if P, then Q. So for example, if there is snow on the ground, then it is winter. And we also looked at the converse of that, which would be flipping your hypothesis and your conclusion. So then you would say if it is winter, then there is snow on the ground. And also, if the statement, both the conditional statement and the converse are true, then we get a biconditional statement that states if, or P, if and only if Q. So I could say there is snow on the ground if and only if it is winter, if it was true in both cases, but it is not. Okay, so that was what we've done before. Now we're going to look at two more types of statements. The first one is an inverse. Okay, so an inverse statement is a statement that is formed by taking the negative, so negating both the hypothesis and the conclusion. Okay, so for example, if my conditional statement says, if a number is divisible by 2, then it is even. We know that that's true. The inverse of that statement would say, if a number is not divisible by 2, then it is not even. Okay, so we negate them both. That's an inverse. And then a contrapositive is a statement that is formed by negating both the hypothesis and the conclusion in the converse. Okay, so we have to flip the hypothesis and the conclusion and then negate them both. So the contrapositive in our above example would be if a number is not even, then it is not divisible by 2. And it's important to note that if we have a conditional statement, if the conditional statement is true, then the contrapositive will be true, and vice versa. This will probably come in handy because sometimes I find my brain doesn't work as well in all of the negatives. So kind of memorizing this, because lots of times we can think about the conditional statement, and then if that's true, the contrapositive will be true. And we also know that if the inverse is true, then the converse is also true. Okay, kind of same thing. If you have a brain like mine where negatives make it confusing, if we remember those two things, then that will help us when we're having to analyze whether they're true or false. Okay, so you will want to have this chart kind of handy because it tells you the order of things. So remember, the conditional statement says if P then Q, the converse if Q then P. Biconditional is P if and only if Q. The inverse is if not P, then not Q, and contrapositive if not Q, then not P. Okay, so we're just going to look at kind of writing these statements out. So it says to write the converse, the inverse, and the contrapositive of each conditional statement. Okay, so I'm going to have to write kind of small here because I don't have a lot of space. But the first one says, if you are over 16, then you can drive. Okay, now when I was looking at this one, I was like, ew, I should have maybe put the word legally in here because I think we all know that there's people under 16 that can drive. Anyway, so we're going to look first at the converse. So if we refer up to our chart above, it'll help us to keep track again. So you'll always want to have this handy. So the conditional statement is if P then Q. So the converse is if Q then P. So we're interchanging our hypothesis and conclusion. Okay, so our converse will look like if you can drive, then you are over 16. Okay, we'll analyze whether these are true or not in the next step, but for right now, we're just getting them down. Then we want to write the inverse. So from looking up here, the inverse is if not P, then not Q. So we're going back to that original conditional statement and negating both. Okay, so the inverse says if you are not 16, then you cannot drive. Right, we're negating them both. And then the last one is the contrapositive. So the contrapositive says that we are going to negate the converse. So basically taking what we have here and negating that. So if you cannot drive, then you are not 16. Okay, so we're going to kind of do number 1 and 2, because number 2 says for each of the above statements, determine if they are true, and if they are false, then provide a counterexample. Okay, so again, it's probably easiest to first look at the conditional statement and the converses, because then we can kind of use this idea up here about if the conditional statement is true, the contrapositive is true, and vice versa. Okay, so the conditional statement says if you are over 16, then you can drive. Okay, so if you are over 16, so imagine that you're over 16, you can drive. Is that necessarily true? I would say no, that is false. Okay, so then a counterexample would be, I know lots of people who are over 16 and are scared to get their driver's license, or just their conditions don't allow them to get their driver's license, or they don't have a car. Maybe you live in Toronto. I bet there's lots of people in Toronto who are over 16 who don't drive, because you just don't drive in big cities like that, right? So I would say false. So a counterexample would be a big city person who never drives. Oopsie. Okay, and then remember it says that if the conditional statement is true or false, then the contrapositive will be the same, right? So my contrapositive then will also be false, because I know I find like the negatives. So if it says if you cannot drive, then you are not 16. So imagine that you are unable to drive, and then you are not 16. Okay, so that is also false because the conditional statement is false. And then if I look at my inverse, right? So those are the converse, sorry, because those are the ones that are positive. So it says if you can drive, then you are over 16. Okay, so my converse is here. If you can drive, so imagine that you can drive, then you're over 16. Well, that's a big fat lie. I mean, if anybody's a farm kid, they know that like you learn to drive probably a lot younger than the age of 16, right? So I would say probably a lie. Okay, and then we know that if my converse is true, then my inverse is true, and vice versa. So if my converse is false, my inverse is also false. Okay, so if you are not 16, then you cannot drive. False. All right, so let's look at B. So we're going to write the converse, inverse, and contrapositive of the natural number. If n is a natural number, then 2n is an even number. Okay, so what I want you to do is I want you to pause the video and write down the converse, inverse, and contrapositive and see if you've got them correct. So come back and check. Okay, so you can check. So the converse would be if 2n is an even number, then n is a natural number. The inverse would say if n is not a natural number, then 2n is not an even number. And the contrapositive says if 2n is not an even number, then n is not a natural number. Okay, so now we're going to look at these statements and see if they are true or false. So this original statement says if n is a natural number, then 2n is an even number. So natural numbers are the counting numbers, 1, 2, 3, 4, 5. So if I was to substitute in 1, 2, 3, 4, 5 for n, I would in fact get a even number. So that is true. And we know from up above that if the conditional statement is true, then the contrapositive is true. So we don't even have to worry ourselves with all those silly negatives. Okay, so we know that that one's true. Now we're going to look at the converse. So the converse says if 2n is an even number, then n is a natural number. Okay, so if I get an even number, 2, 4, 6, 8, 10, then n must be natural. This actually isn't true because -2, -4, -6, -8 are also even numbers. And I would have to put in -1, -2, -3, -4 for my n value, which are not natural numbers, those are integers. So this is false. Okay, so I could say my counterexample would be like n equals -2. So if I put in -2, I get an even number out. Okay, and we know that if the converse is true or false, then the inverse is also false. So, and again, because the conditional statement was true and this one was false, this is not a biconditional statement. And the same thing in the first one, both of them were false, so not a biconditional statement. Okay, so you can go ahead and practice with writing conditional statements, converses, inverses, contrapositives on the next page.